So now that we have gone through sections that tell us how to differentiate logarithm and exponential functions, we have a set of problems here. So I would like that anybody would look at any particular problem and explain to me why that problem seems difficult to you. Doesn't mean you can't do it, but tell me why it seems like it might be difficult.
Can I go?
Yes.
Okay, as for 5, I just usually get confused with the X on the outside because I usually don't know what to do if it cancels out or not.
And which one, number 5?
Mm-hmm.
Okay, so the X on the outside is definitely not going to cancel with anything. There's nothing it can divide with. It would need to have maybe an X or an X squared or an X cubed or some power of X in the denominator for it to be able to divide. Okay.
Okay.
All right, good question. Excellent. Anybody else? Some of you tell me I was in class, but I don't know you're here because you don't talk. Give me an idea.
Also,
oh, go ahead.
It was me again. Sorry.
Mhm.
9.
Number
Because when I
9.
was doing the homework, and I didn't get 9, and I kept like trying to figure out.
Okay, you're breaking up for a sec. Wait till you come back. So number 9, y is equal to x squared log base 4 of x. Okay, so anybody want to give me an idea of how to tackle that problem?
Hi, Dr. Locke, it's Ezekiel. Do we by chance use the chain rule for this one?
Okay, so in number 9, we are not going to actually need the chain rule.
Do you do the exponent first?
Well, in number 9, 9 is a product rule. Okay, so let's start with number 9. Okay, so we'll start with number 9. We can do these in any order that we wish, so let's start there. All right, so number 9 is y is equal to x squared times the log base 4 of x. All right, so this is going to be a product rule. So now if you guys remember when we were doing this before, how do you differentiate log base 4 of x? Because I see I have 2 functions. So x squared is my first function, and then my other function is log base 4 of x. And when I go to use my product rule, I need to already have an idea of what the derivative of log base 4 of x is. Okay, so now if you look back in your notes, I derived it and then I told you what it was. So I said that the log base 4 of x is the natural log of x divided by the natural log of 4. And the natural log of 4 is a number. So we can actually pull it out. So therefore, the only thing I'm differentiating is log of x. And what's the derivative of the log of x?
Is it just 1?
Yeah, isn't it just 1?
Okay, it's 1 over x.
1 over x.
Right, so it's 1 over x. So therefore, the derivative with respect to x of log base 4 of x, well, I have the 1 over log base 4 already there because that thing is a constant. But the derivative then of the log of x gives me 1 over x. So this is 1 over x times the natural log of 4. Okay, so now I know, now I have my derivative ready. Okay, I already have that's somewhere on my paper. I've figured that thing out. So now I can do a product rule. So y prime says take the derivative of the first, which is 2x, and multiply by the second. So that's going to give me log base 4 of x Then I'm going to add the first, which is x squared, and multiply by the derivative of the second, but we've already computed that. We know that the derivative of the second is 1 over x times the natural log of 4. All right, so I can simplify this now. So I get 2x, the log base 4 of x, and then the x squared over the x. Now here's a case, Ayana, where I'm going to be able to cancel the x, okay, because they're not attached to anything. So that I'm going to be able to cancel 1x and get x over the natural log of 4. So the natural log of 4 will still stay. And that's the answer to number 9. Okay, so number 9, the difficult part was not the product rule. The difficult part was recognizing that I just need to find the derivative of log base 4 of x. And there's no chain rule because I don't have anything that is a function of a function. So x squared is one function, log base 4 of x is one function. Nothing is a function of a function, so I don't have to do that. Okay,
Thank you.
no problem.
Yeah, that makes sense, actually. Thanks a lot.
Okay, all right, so we've tackled number 9. Is there another one that seems like, okay, that one's fairly easy, let's do that one? Or another one that looks like, oh my goodness, that's kind of difficult. What am I going to do?
Can we do number 5?
Number 5, okay. So number 5 is going to require logarithmic differentiation. Okay, so number 5 is going to require us to simplify it first. Otherwise, we have a product rule, we have a quotient rule, and we have 2 chain rules. Okay, so that's a pretty hefty problem if I was going to try to do it without using the natural log. So the first thing I'm going to do is simplify this before I take the derivative. So let's take the logarithm of both sides. So when I do that, I'm going to get the natural log of y. And then I'm going to get the natural log of this whole thing. And I'm going to rewrite this as x squared plus 1 to the 1/2 power. That's much easier for me to work with. And then I'm going to divide by, I have x plus 1 to the 2/3 power. Now I can use my properties of logs to simplify the right-hand side. So how will I simplify the right-hand side? So we got to remember that the natural log of a times b is the natural log of a plus the natural log of b, and the natural log of a over b is the natural log of a minus the natural log of b. So now I have 3 things. So I have the natural log of a times b over c. That's what we're looking at. 3 different functions. X is one function. X squared plus 1 to the 1/2 is a second function. And x squared plus 1 to the 2/3 is a third function, and it's in the denominator. So I have 2 things multiplied and then the one in the denominator. So just using the denominator rule, I can make this the natural log of a times b minus the natural log of C. Does everybody see that? So I use the quotient rule. All right, so I basically said the natural log of the quotient is the difference of the logs. So now I can do something with this middle term. This middle term here, I can split it up using the one in the top. So this turns out to be the natural log of A plus the natural log of B minus the natural log of C. So now that I know what this looks like, so this is the natural log of A times B over C. Now I know what to do. Now I can actually use that in my problem that I have here. So now what am I going to do? How am I going to write this? So I get the natural log of Y on the left. So what am I going to get on the right?
The natural log of X.
The natural log of X.
Would it be to the half?
No, because the 1/2 is not touching that.
Okay, so then plus the natural log of X squared plus 1 to the half.
Okay,
Minus the natural log of X plus 1 to the third, 2/3.
okay, that is absolutely correct and it's perfect. Okay, so we just used our properties over here. All right, I always like to put properties in squares because I think that when you go back and look at it, that square stands out and you're like, okay, I got to remember that. Okay, so we have those properties there, okay? All right, so I should have waited because there's another property now that I need. So now I need the fact that if I take the natural log of A to the B, I can bring the B down and get natural log of A. Okay, so do you see anything that I can further simplify? So I have the natural log of Y. Anything else I can further simplify?
Equals the natural log of X plus half natural log of X squared plus 1 minus 2/3 natural log X plus 1.
Okay, so at this point right here, we are done simplifying. There's nothing else I can do. Now what I need to do is actually do a derivative. So we need to actually do the derivative. Now, remember, Y is a function of X. So when I take the derivative of it, I have to use the chain rule. So the derivative on this side is going to give me 1 over Y, which is the derivative of log of Y, but I have to multiply by dy dx because that comes from the chain rule. Now, on the right-hand side, I just differentiate. And there is one where I'm going to have a major chain rule. So what I want you to do is I want you to go through and differentiate each individual term. I really appreciate those who have their cameras on because it helps me to be able to see if you understand. I can go by what your face is saying and give you additional support if you need it.
Dr. Locke, did you want us to write down the
I want you to
derivatives of?
yep, I want you to complete the right-hand side. That's correct.
Okay.
And when you're ready to chime in and tell me what the right-hand side should look like, you can either raise your hand or you can just unmute yourself. Okay, I think you've had ample time. So somebody want to give me the answer? What is the derivative of the right-hand side? Let's start with log x. Let's just do it piece by piece. What's the derivative of log x?
1 over x.
1 over x, good. Okay, the next one, I have a 1/2. And then what is the derivative of the log of the quantity x squared plus 1?
It's going to be a half of natural log of 2x.
Okay. Well, let me think about where you got a little confused. How do you take the derivative of the log of u? What do you do with it? Anytime you take the derivative of the log of something, you immediately throw it in the basement.
Would it be 1 over x squared plus 1?
Okay, so I'm going to have 1 over x squared plus 1. But what do I need to then do with the x squared plus 1? I have a chain rule, so I have to keep going.
Multiplied times the derivative of
That's
the-
right. So I have to multiply by 2x.
Oh yeah, that's the part I forgot. 1 over x squared plus 1. That's the part that I actually forgot.
And there's no log left. The log is gone. You said the log of 2x. So the logarithm actually disappears as well. We differentiated that function. Okay.
Okay, thank you.
No problem. Next piece. Derivative of the log of the quantity x plus 1. This one's easier than the last piece.
So like in the basement, it goes x plus 1.
Very good. And then I have 1 here, and I need to multiply by the derivative of x plus 1, which is
1.
1.
1.
So we're done. Okay, good. All right, so let's simplify that. So we get 1 over y, dy dx is 1 over x, plus the 2's divide out. So I get x over x squared plus 1. And then I get minus 2/3 times 1 over x plus 1. Okay, now what am I trying to solve for, guys? We want y prime. So we're trying to solve for dy dx. So in order to get that, that says, let's multiply the whole thing by y. So now dy dx is going to take 1 over x plus x over x squared plus 1 minus 2/3 1 over x plus 1 and multiply that whole thing by y. Okay, I think we're done as soon as we put y in. Well, what was y? So y is way back here. Okay. So that's y. So we have to come down here and get dy dx. It's going to take this 1 over x plus x over x squared plus 1 minus 2/3 times 1 over x plus 1. And we're going to multiply that whole thing by y. Okay. And that's the answer.
So you said we're dividing it?
We're dividing what?
Why?
No, we multiplied by y. Here, y was in the denominator. So when I multiply both sides,
So you just okay. I was reading it differently. My bad.
okay. So I took what I had and then I just input what y was. I have to multiply by y. And so I just went back and grabbed y and stuck it in there.
I have a question.
Yes.
Like, what did the 1/2 go?
Okay, so back at this step, this 2 divided with that 2. Maria, do you see it?
No, my screen is frozen right now. Like freeze right
Okay.
now.
All right, so let me do it again. All right, so go back to this step right here. Can you
Okay.
see that?
Mm-hmm.
Okay, so in that step, this 2 divided with that 2.
Oh, okay, I see.
So that's our 1/2 was able to be multiplied out.
Thank you.
You're welcome. All right, that was one of the tough ones. There's a bunch of these that are a lot easier. So now we've done 1 and 5. I'm sorry, we've done 9 and 5.
So will we just keep it like that? Keep it.
Oh, that's it. We can't do anything with that.
Okay.
Oh yeah, that's it. Normally, I will simplify a problem until you can't simplify it anymore. So when I usually put a period next to something, that's the way you leave it. Okay, which next one do you want to tackle? Which one looks good to you?
Can we do number 7?
Number 7, okay. All right. Can anybody just give me a hint as to what kind of rules I'm going to have to use in order to do number 7? I have two functions.
E to sine x.
So I have two functions. So therefore, I'm definitely going to need the product rule.
I was about to say you could do the product rule.
Okay. But when I do the product rule, I'm also going to need to use
Chain rule.
chain rule. That's right. Okay. So the product rule says we're going to do the derivative of the first. So now we remember that the derivative with respect to x of e to the u of x is e to the u of x, but we have to multiply by u prime of x after we're done. So how do we do the derivative of e to the sine x?
Oh, would you put it as e to the sine x times cosine x?
That's correct.
Okay.
So that's the first piece. And then you just multiply by the second. Okay, so now we have the first. So now we have to multiply by the derivative of the second. How are we going to tackle that? How do you take the derivative of the log of x squared?
Would it be 1 over x squared times 2x?
That's exactly right. Okay, so we're going to put the x squared in the basement and then multiply by its derivative, which is 2x. And then the derivative of 1 is 0. So now I'm going to factor out my e to the sine of x. My first term is going to be the cosine of x times the natural log of x squared plus 1. And my second term is just 2 over x. Okay, So
How did you
now-
get 2x?
how did we get 2x?
Yes.
Okay, because when we take the derivative with respect to x of the log of u of x, you put u of x in the basement, and then you have to multiply by its derivative. So when you put x squared down here, you have to multiply by the derivative of x squared, and you
Oh,
get 2x.
I get that, but like I meant the 2 divided by x.
Oh, the 1x divides with x squared and leaves 1x in the denominator.
Oh, I see that now. I'm sorry.
No problem. Believe me, you're not the only one who may not have seen it. It's okay. Very good questions. All right. Now we've done 5, 7, and 9. What else looks good to you?
Is it possible if we can go over number 2, because I think we may have done something similar yesterday?
Okay, x times the log of x squared. So number 2. Okay, do all my notes look like that? Oh, no, I do have y prime there. Okay, so I wrote y prime. That one we did logarithmic differentiation. This one, that's what y prime is. And now we can do this. Okay, so now I'm going to have what rules? I see 2 rules for sure I have to use.
We're
Product.
gonna use the
Product
Product rule?
rule.
Product rule and
The chain rule?
the chain rule. The chain rule. Okay. All right. So we start with the product rule. So that says the first, we're going to take the derivative of the first. Well, that's just 1. Okay. And since it's multiplied, I'm not going to bother to write the 1. And then I need the derivative of the second. Now here is where I have to use the chain rule. So the 2 has to come down and give me the log of x to the first power. And then I have to take the derivative of what's inside, which gives me 1 over x. Then I'm going to do the first. So that was, oh, I did that wrong. So derivative of the first times the second. I'm supposed to write this first. Then it is the first, which is x, times the derivative of the second. So now I bring the 2 down, the log of x to the first power, and then I multiply by the derivative of the log of x. Okay. So I did the derivative of the first times the second, plus the first times the derivative of the second, where I had to use the chain rule. So that became 2. So I took the derivative of u of x squared. So that is 2 times u of x. Then I have to multiply by its derivative. Okay, so now I get y prime is the natural log of x quantity squared plus 2 times the natural log of x, because this x, the x in the numerator and the x in the denominator divide out. Okay. All right, we have a little bit more time. We still have about 9 minutes. Several more problems here. Okay, I'm going to choose one. I choose number 11. Now we can do number 11 2 different ways. Okay, number 11 can be done 2 different ways, but let's just use the product rule first. So if we do the product rule, what do we get?
So I want to try this one. If you're doing the product rule, would it be? Hold on. No, would it be the derivative of log of 7x times log of 3x plus log of 7x times the derivative of log of 3x?
Okay.
The derivative of log of 7x, would it just change to the natural log of 7?
Okay, so when you do the derivative of this, let's go back just a little bit. Here we go. All right, let me just write it out. So the derivative with respect to x of the log base a of x is 1 over x times the log of a.
So it would be 1 over x times natural log of 7.
And that's multiplied by the log base 3 of x plus
Log of base 7 times the derivative of a log base 3 of x, which is 1 over x times the natural log of 3.
all done.
Wait, that's it?
Yeah. Now, we could simplify it a little bit more. I could say that this is 1 over x times the natural log of 7, and this is the natural log of x divided by the natural log of 3. And then I could make this the natural log of x over the natural log of 7 times 1 over x, the natural log of 3. And then I could miraculously realize that they're the same thing. So I end up with 2 times, well, 2 over x times the natural log of 3 times the natural log of 7 times the natural log of x. So I was okay here, but I could simplify and get to there. All right, looking good. Have 3 minutes. I don't know which one we can squeeze in 3 minutes. Oh, let's do number 8. Number 8 looks kind of scary. y is equal to 2 to the sine of 2x. Okay, now we learned that the derivative with respect to x of a to the u of x, this is that equivalent problem, is a to the u of x, but then I have to multiply by u prime of x, and because that's not e, I have to multiply by the log of a. All right, anybody want to take a stab at it?
We do the log of both sides.
We could. Now you could do that using logarithmic differentiation, but it's probably best to just use 1 minute. It's probably best to just use this property right that I just wrote. Let's just use that. Okay. All right, so since we're pressed for time, I'm going to walk you through it. So here, a is 2. So when I take the derivative, I'm going to get itself 2 times the sine of 2x, just like the exponential. But I have to take the derivative of the sine of x. And the derivative of the sine of 2x is the cosine of 2x. But then I have to multiply by 2 for the chain rule. And then I still have the natural log of 2. So I get y prime is going to give me the natural log of 2 times the cosine of 2x. And watch this, times 2 to the sine of 2x plus 1. Now, where did that come from? That came from the sine of 2x and 2 to the first. So you add the exponents. Okay, I think this was a rather fun recitation. I enjoyed doing these problems. I hope you did too.
Dr. Locke, you said you uploaded these on